Hi everyone. Right, so my confession is I'm not a data visualization expert. As you can see, I work at DataSIF, so I'm lucky enough to sit next to Paul and peer over his desk and see some stunning stuff. Now, what I'm very much interested in is real-time data, so, and most recently visualizing real-time data. So my background is in web content and internet technologies in general. And I stumbled across this library a couple of months ago called D3, and kind of the being in the real-time data space and the real-time visualizations really started to fascinate me. So see that bottom bullet point there, new to D3. So just curious, how many people here have actually seen D3 or used it or know of it? Right, okay, so you guys are probably all going to know a lot more than I do. But so the idea of this presentation really is just to run through and talk about my experiences with building stuff with D3, what I've learned from a data visualization perspective, what I've learned kind of do's and don'ts with real-time data. And it kind of got me thinking when I started putting a slide deck together, how much stuff's changed in such a short period of time with regards to data visualization. So, you start looking back at some of the browser technologies. Getting data to the browser itself was complex, time-consuming. I need plugins, HTML tables, and some of those images kind of, anyone in the, been in the internet technology business will, run shivers down your spine, I'm sure. And things have obviously changed. There's a huge wealth of changes in technologies, and showing this example here gives you a perfect demonstration of the types of things you can render very, very easily just in a browser with no plugins and actually very little skill due to things like D3. Things have got bigger, data's got bigger, and now we can deliver data in real time. So, there's this whole paradigm shift in that we're not going from a Excel spreadsheet that sort of I'll pick a few cells and I'll render those in a pie chart or something. It really is a different world of what we can do in the browser, where we can get data to, and then how we can actually interact with that data as well. So I kind of just jotted down a few thoughts around, what's driving this evolution, and some of the key points here. Obviously, there's more data available. If you think of the impact that social networks have had, mobile tablet devices, and the sheer amount of data being generated is, pushing the whole big data industry forward. Data interoperability and standards are getting better and better and easier to deploy. So I think anyone deploying, a serious web application around data that kind of silos that environment is probably going to lose their job very quickly. It's now, expected that data is interoperable between different services, and that's becoming easier and easier to do. So, with the introduction of low-cost cloud environments, Amazon, you're completely changing the way that we deploy architectures, that we can store data, and then finally get data out to our customers. Some of the internet technologies that are really changing the way that we interact with browsers and visualizations, so polling and push techniques, so HTML5 on the horizon, technologies such as WebSockets, just making stuff completely much faster, lower latency, and really driving forward what we can do in a browser. And then obviously browser technologies themselves. So, if you were to take something like Chrome and put it next to IE 5.5, there's a different world there completely. And, JavaScript engines have got faster, richer. JavaScript libraries, obviously, why we're here, have got much faster. And then, as I say, advantages in HTML and CSS have all led to this explosion in, kind of visualizations and being able to deliver those quickly and easily. So, as the slide says, we now have the data and it's real time. What can we do with it visually? So as I said, I stumbled on a library called D3 that obviously a large percentage of you heard about, and it's written by a guy called Mike Bostock. You can see the GitHub address there where all of the documentation is, all the library is, and most importantly, all of the fantastic examples. So D3 stands for Data-Driven Documents. and it's a framework to create browser-based visualizations. But most importantly, one of the key concepts is that it allows you to easily map data onto the DOM or items within your browser page. So I wrote down a couple of the thoughts that hit me around, why you'd use D3. So as I say, simple to connect data elements with DOM elements. It's got a jQuery style chaining, so you can chain commands together very easily and simply. Plays nicely with JSON, CSV, XML, and remote HTTP requests. So what I found coming into this kind of as a newbie is saying, well, okay, I've got a spreadsheet in it, let's see what I can do with it. And you can go right from there, right up to running off, capturing web services and whatever you want. SVG support, so when you start wanting to push the limits of the browser, we've got fantastic animation capabilities, pixel perfect displays, and then most importantly as well, helpers for access calculations. So when you start doing things in real time, it actually gets quite complex as to how you're going to display that data, calculating how stuff changes and moves across time, and there's a ton of API methods there to help you out and to get you up and running. And then finally, I was kind of blown away by some of the demos. I mean, literally looked at a few of the representations and literally was just stunned. And I guess speaking to a data visualization audience, you're probably not in the same league as me as regarding to being stunned. But, some of these examples are just fantastic. I mean, pretty much any type of visualization you can think of, you can pretty much render using D3. There's a couple more examples. And these are, as I say, these are all nicely documented, great examples. You can just go and have a look on the site and a few lines of JavaScript. And the nice thing as well is you get sample data files, so you can go and have a look at actually how the data is presented, what that format is, and how that can be manipulated. So what I've done, I mean, the whole idea of this presentation really was to demonstrate an application I've built of showing real-time data, but kind of an end-to-end stack. So once I started looking at D3, I started thinking, well, how can I get the data to the browser in an efficient manner? How can I get real-time data in there? And perhaps I want to manipulate and work out different calculations on that data before it gets to the browser. And obviously working at DataSift, I've got a superb real-time data source available to me. So I decided to build kind of an end-to-end stack. So what I'll run through a bit later is an example of taking that data source, providing that into the environment and manipulating that before it gets to the browser as well. And running through that process, I mean, some of the things that I learned and sort of sprang to mind. Obviously, your visualizations rely on a good data source. So if that's wrong or incorrectly formatted or imperformant, you're going to have problems. So have a think about what services you need from that data before you start, and how are those going to change. So if I'm obviously in a real-time data world, how often does that change, and what parts of the data are going to change? So think about, normalization of different sources is a key one. So if I'm taking data sources in from different locations, how am I going to normalize those, merge those together in a realistic manner? Consistency. Obviously, you don't want your data falling apart at certain or being inaccurate in certain areas because your data is not correct. Error checking kind of goes without saying. Interoperability and size and latency. So when you come into the real-time world, it's kind of a case of, the minimum bytes you can put down the wire and render in the browser are going to give you the best performance. So looking at the Firehose data, this is a graph that came from DataSift, and right now I think we're receiving over 300 million tweets a day, so 3,000 odd a second, which is pretty high frequency. It's sort of not on the scale of any sort of low latency trading, but typically you're not rendering low latency trading data within browsers. But this sorts of volume obviously has its difficulties with serving that to the browser, and I kind of phrase that with big data versus the browser, and big data is going to win. So you need to get that data down. So if you start looking at that sort of volume, what is it that's of interest to me right now? Filtering, kind of an obvious one. In the DataSift world, you can write a filter against the Firehose to say, I'm only interested in tweets on a specific subject. But outside of the Firehose world, you've got to reduce that down. Rate limits and thresholds are a great one, so you can limit your number of interactions coming in by a percentage or something, or have barriers that you can stay within. It's very, very useful. Most people store that data in some way, so if you want to do some calculations on that data, work out running averages and weightings and things of that nature, or merge that data with different sources, it's highly likely you may persist that in a database. So again, that comes into the whole real-time world of queues and buses and all that technology that will help you collect and collate that data into a single location. So effectively, control accurately what reaches the browser. Be really stringent about what data is it that actually gets sent down the wire. We've all had situations where browsers start hanging on us because there's too much memory or CPUs being consumed, and that's easy to do in the real-time environment. So one of the critical decisions, looking at real-time data visualizations, how often do I need to update? If I'm sort of rendering averages every 5 minutes, well, there's no point sort of refreshing any time in between those values. And this middle one's kind of interesting. So what type of interactions do I need? So we kind of think of real-time visualizations as being very one way, where I'm consuming the data, but there's nothing stopping you selecting parts of that graph that you're interested in, and also letting other colleagues and friends and other viewers or people of a specific group know what you're looking at and know what you're manipulating. So we can even have sort of client-to-client communications, and there's no reason why we shouldn't be able to do that. Also, think about older and slower browsers, and obviously one I haven't put up here is mobile. So, how fast can JavaScript computation be done? How effective is your DOM manipulation? Are you going to slow down the browser? Are you going to cause crashes? Kind of critical. And, progressively falling back to non-real-time may well be a good option in certain environments where you're detecting the browser can't support certain technologies. We'll fall back to whatever technology you need to. Skip over this fairly quickly, but the whole idea of, in the last couple of years, we've introduced a typical client-server techniques for requesting data is obviously being the HTTP GET and polling for data. So, requesting data from a server, that's coming back, and certainly rendering real-time data is, absolutely fine in that fashion. So, you can be doing sort of AJAX-based requests, updating that page every few seconds, if the nature of your real-time data is suitable. So a periodic refresh is quite typical, where something will update every few seconds, and it gives the effect that it's kind of a real-time rendering. Push technologies are obviously becoming more and more popular recently. It can be difficult with certain technologies to implement. There's many different methods for implementing push technologies. All have their pros and cons. But on the horizon, we have HTML5 WebSockets, which really is a whole step forward on low latency push technologies, bidirectional through a browser. And certain browsers support that right now. Tweet comes into the system, it will count that and visualize that in a graph. So what I've kind of done is run through the entire stack that I've used to do that, to give people an idea, and also to make the code available that people can take and just start up and have a play with. So as my data source, I use DataSift. You don't have to, of course, use that. It could be any type of real-time data. I used Node.js as my server-side language. So anyone here not familiar with Node.js? Okay, so a fair few. So effectively, Node is it's server-side JavaScript, and it's a programming language designed for building basically internet applications. Very efficient, and you can do things like asynchronous callbacks, so you kind of fire and forget. And it's built around Google's V8 JavaScript engine. So it's nice when you're using JavaScript on the front end, you can also use JavaScript on the back end. Express is a framework that sits within Node, and it basically does the web-based side of things, so being able to deliver static pages, so delivering our D3 JavaScript files, inspired by Sinatra. And then we use Socket.io for the connectivity. So what I'm doing here is a real-time push from the server out to any connected browsers. Anytime a new piece of data comes in, we take that, we look at it, and then we fire it out to all the different browsers. And Socket.io is a plugin to do that, and it basically supports WebSockets. So if a browser supports WebSockets, it will use it, and then it gracefully falls back to slower or different connectivity if WebSockets isn't supported. And then obviously we have D3 at the bottom here, which I'm using on the client side to actually do the visualizations and render. This is my Node app, and it's 30-odd lines long. I don't know if you can read this very well, but I've kind of highlighted a few of the key points. So pull Socket.io library into there. Can't see this very well. That is the rendering of the static items. So that's where we tell Express to have a folder, look in there for all of our JavaScript files, our CSS, our HTML, rendering those static files. And we can also define routes as well within Express. So we can give specific paths to certain locations. This is my DataSift clients script, and as I say, I don't know if you can see this very well, but it's really, really simple that we have a Node client out the box, and basically we get alerted when things happen. So what's that one? So that's the DataSift stream. Yeah, sorry, I can't see on the screen here, so I'm having to peer around a bit. So when any of these get called basically on different events. So when I connect, I get an event fires. When I get a new piece of data, an event fires. When a delete comes through. So the important one is down the bottom here. You can see that when we receive an interaction, that event's going to fire, and our JSON, we get JSON from DataSift, and therefore I have a JSON array comes into the software. So how do we get that data then from the server to the client? And using Socket, it's incredibly easy. So you can see here that I've got, I'm saying when the DataSift interaction comes in, Socket.io gives us this emit method, and it basically, all I do is I throw the JSON array into that, and the emit throws that out to any concurrently connected clients. So it doesn't matter how many browsers we've got up and running, all accessing that same server, they're going to get updated simultaneously. So it just takes all of the legwork out of pushing that data out. And that's it. So that's the server side. We've got the data out. Every time we get a new interaction, it hits our client side. So all we have to do is pick that data up on the client side and give that into D3. And again, Socket has a very nice method for doing that. Socket on data will fire every time a piece of data comes in, and all I'm doing is incrementing a count here. So all my application is doing is a counter, and it's going to give us a visual representation of the frequency of that data coming in. So I just increment a count, simple variable. And this is my D3, so I've taken the chunk out of here. So I'll show you the link to the source code afterwards so you can have a good look. But this is the bit that does the animation. So when a new piece of content comes in, we need to update the X and the Y axis. We need to update the X axis based on time, so we're going to have a moving time along the bottom. We need to update the line, which is the average number of interactions coming in a second. And then we also might want to rescale the Y-axis based on the volume of interactions coming in. So if I have 1, 2, 3 a second, and that jumps up to 70 a second, we need to adjust the Y-axis to do that as well. So you'll see the 3 transitions in there. Adding the new data item. Yeah, so what this does is we just keep the any data items that come in jump into an object. New one goes in, and you'll see down the bottom, and we drop it out. And then you've got those 3 transitions there. So the line itself, the time along the X, and then the Y if the actual range varies. And then at the bottom there, we just drop off the old piece of data that we've already processed. So I was going to do a live demonstration, but I've been told the internet connection is not very reliable. It just so happens I have a video that I brought with me, which should demonstrate what I'm talking about. If I can find the mouse. There we go. So hopefully let's have a look. Right, so what I'm doing here is I'm setting up a stream in DataSift. So this bit's not relevant to obviously visualizing your data, but I'm setting up a real-time source here. It's just a really simple keyword search. So I'm setting up a data source, and I want it to be quite rich, so doing a keyword search for Apple, iPod, iPad, iTunes. And once that's set up, we can then use that stream to power our visualization. So you can see the data coming through there, and I click the Use Stream button, and we get a unique ID of that stream. So there's a hash key there, and there's my API key as well. So I start up my Node app, and then all we do is we actually load the web page, and if I stop it there, so this is just the rendering of the web page itself. I've put a few options in the top right-hand corner that you can just drop in your DataSift keys and stuff, and that's exactly what I do now. And then that will just start consuming that data. So I grab my API key and my username. I will be changing that after this presentation. So. And then grab the ID of the hash, which is the stream I want. Click the Submit button, and then you'll see that a number of things happen. So you can see the y-axis is scaling based on the number of interactions that are coming in. We've got a total interactions counter up the top left, so you can see how many messages are coming in. And then I'm just rendering that against the time on the x-axis is actually moving in real time. So that's it, but as I say, hopefully it's useful to go from the full stack right the way through to the end result. And as I say, I've make this code available as well. Which you can find it there on GitHub. If anyone's interested, you can pull down that code and have a play, or feel free to contact me, and I can answer any questions. Thank you very much.